Loops are another foundational skill in computer science, although technically they are entirely optional. You could write all the code in the whole world that exists without any loops. You just have a miserable life. What do loops allow us to do? Well, at their base, they allow us to just repeat something over and over again, looping it. If you think about if you got caught in a time loop in your day, repeated over and over again, then you'd kind of probably be pretty bored. And let's hope this video doesn't get any more boring than it kind of is trending. So let's dive right into the content here. So the idea of a loop is you can avoid it by, let's say, I have a method or a behavior in my program that says do. What does do do? Well, let's be a little more specific. Let's say do my chores. So I want this program to do my chores for me. So I've created some logic somewhere else. This is just referencing some other behaviors. And so do my chores, and then, but I want them to do my chores again. I don't just want them to do it once. So I can say, you know what, program, you know what, do my chores a second time. I want you to do them again. Okay, twice. But I want you to do them again, just to like really meticulously do the cleaning and get everything cleaned up really well. And I could have this do my chores 1,000 times. I just write out do chores 1,000 times. No problem. But this is really cumbersome and also really ugly to look at. Just a big long line of do chores or whatever behavior again and again. Not good code and really repetitive, wasteful, inefficient. No, not required technically. I could just write it all out like this. But really, what I want to somehow communicate in my code is do chores times 1,000. Do this 1,000 times. Now, this is not the way we write it. This is pseudocode, meaning just a representation of the algorithm or logical process I'm thinking of. But this is kind of what we're trying to represent. Do this 1,000 times. And so we kind of have two different ways of running loops in computer programming. The first way that we have is through what's called a for loop. And a for loop is useful when we know how many times we want something to run. We know the conditions for it. Maybe we say, do chores as many times as it takes until everything is spotless, and then stop. Don't continue doing the chores once things are actually cleaned up. Or maybe we say, do my chores 10 times, and then maybe I should get back to it myself. Or maybe we have some other situation. We have something that we have a request from the user. It wants to kind of calculate something no more times than they need, because they maybe have to pay you for the process of calculating it. And so they request this to be calculated 20 times. You can create a for loop that says, in whatever way that your coding language that you're doing, it's a bit different between Java and Python, but you say, do this whole calculation set 20 times for this person, no more, no less. And it will perform that operation again and again in a nice, simple, summarized way. However, we have another option here, which is a while loop. That's a bit more for when we don't know how many times something needs to happen. So the while loop, we say, while some condition is in place, continue to do this. So back to that kind of robot concept. While my room isn't meticulous, clean it up. I'm not sure how many times it's going to take you to do my chores or to clean it to get there, because maybe you messed some things up. Maybe my room's just that awful. Probably the case for some of you. But I don't know how many times it's going to take, but keep on doing it until you're done. If it takes 1,000,000 times, I want you to do it 1,000,000 times. It's that important to me. So this while loop is going to keep on running. So a for loop, we have this idea of this cyclical process. Start at the beginning, perform something, and then come back to the start. But I have kind of a counter built into it. Some kind of a, maybe I say do it 8 times. Once it's gone around the loop once, it has 7 times left. Once it's gone around the loop again, it has 6 times left, and it will do it all the way to the end where I say if you hit 0, then break out of the loop. The loop is done, exit, and continue on to the next part of the logic. In a while loop, the way that it works is that we have, instead of kind of keeping track of the number of times that we tell it to operate, we instead have some condition. This condition wants to kick us out, but it will only kick us out when it's been met. I'm a parent. I have a little 2.5-year-old and also a 2-month-old. 2-month-old, I'm tired. And my 2.5-year-old tests me sometimes with his troublesome behavior. And sometimes we end up in a while loop condition, and sometimes we end up in a for loop condition. Maybe I say, I want you to clean up 10 pieces of garbage before you can play with your toys after dinner. So go pick up a piece of garbage, and take it to the garbage can. 10 times. 1, 2, 3. Repeats the behavior 10 times in a for loop, a preset number of times. In a while loop, though, I might say, you don't get to play with your toy, this other toy, until you've cleaned up your first toy. Because if you don't, they think the room's getting a complete mess. So you can't play with this until this is cleaned up. And doesn't matter what else you do or say, until that's cleaned up, you cannot touch this. This condition has to be met. So my son can go and throw a temper tantrum in the corner, or go read his book, or go stomp around and run around and cause trouble. He can do whatever he wants, but until this condition is met, he won't get to play with this toy, which means potentially he might never play with this toy again, because if he never cleans up, this toy is not an option. This is the danger that you have to be careful of with while loops in your code, because you can end up with infinite loops. If this condition is never met, there's no guaranteed endpoint like in a for loop. You might never reach that condition, meaning that your code performs the same thing over and over and over infinitely. The computer's too dumb to realize that it needs to stop at some point, which will then, of course, crash your program, because infinitely repeating the same thing is not almost certainly going to be the outcome that you want for your program. So in loops, it's just a nice way of, instead of writing out instructions a bajillion times over and over, we can summarize repeated behaviors in nice condensed manners, either with a known number of iterations or an unknown number of iterations that rely on some condition to terminate. And that's looping in computer science.